Hello everyone and welcome in a new video. I restart the channel. Don't forget to subscribe to the channel to not miss the next video. Today this is the 11th tutorial about Docker. We'll see how Docker implement containers behind the scene. What does Docker use to implement containers? So let's go. And the purpose of this video is to discover what is a high-level container runtime versus the low-level container runtime. This is very important to know it when you use Docker. So Docker is not the only one container runtime. Maybe you know that we have LXC or Creo or containerd, runC, crun. runC is in Golang, crun is in C language, or Podman. The implementation about all of this container runtime is different, and this is very interesting to know it. And Docker is not the main container runtime that runs your containers. It's very, very important to know it. For example, if you use Kubernetes, in Kubernetes, you can't use directly Docker. You use maybe containerd or CRO or other container runtime, but Docker is deprecated. I don't know, since the 1.24 version, if I remember well. So this is not the only one container runtime. It's important to know it. And Docker is a high-level container runtime. Docker uses other container runtime behind the scene to operate C groups and namespaces. It's important to know every container runtime have a unique purpose to set and define C groups and namespaces, to reserve, to allocate resources with C groups, and to create an isolation with namespaces. How work Docker when we told that when you use Docker, you use Docker CLI. This is just a CLI, like a bash script, but this is in Golang language, and this CLI allows you to manage Docker containers easily, of course, but the CLI is an implementation that allows you to manage and to use the Docker engine. Docker engine has the particularity to run as a daemon. This is when your process run always. For example, Podman, another container runtime, high level, run only when you set, define, or manage your container, not always. And when you use a Docker engine, behind this high-level container runtime, you use another high-level container runtime named containerd. Containerd was developed by a Docker company, and this tool was free and give to the open source community. If I remember well, I think this is CNCF. This is containerd is another high-level container runtime. That means this is not the last level of our container runtime. To define namespaces and C groups, containerd use another low-level container runtime named runC. runC was developed in Golang language, and this is runC, who is the last level of container runtime, low-level container runtime. That means this is runC who is defined in namespaces and C groups. This is very important to know it. This is runC who managed the OCI, Open Container Initiative format to define namespaces and C groups. So just if we summarize it, we have a high level container runtime. That means we don't not directly implement OCI model. So, for example, high-level container runtimes is, in our case, Docker Engine and Containerd. Docker and Containerd was implemented to easy to use for current user. This is very easy to manage your container with Docker CLI, but if you don't have Docker CLI, we'll see it just after. This is a little bit complicated to do it manually. For example, Containerd, what allows Containerd? Containerd allows you to pull image. You can't pull images with runC directly. So Containerd provides this functionality to allow you to pull images in a relative easily and manage network and volume. runC is just a low-level container runtime, as I said, and the unique purpose of this container runtime is to implement directly the OCI model. Another example, if you just take Cryo, this is another container runtime. You can use it, for example, in Kubernetes if you want. You don't have so many container runtime level. You just have two container runtime, Cree and Cryo. This is a low-level container runtime to manage namespaces and C groups. Let's take a bit of terminal to show it with a demo. If I take here my virtual machine, I have just a Docker installed, and I want to show you some example. Let's go and start with just use runC. runC is a low-level container runtime, and we have a command runC. If you just install Docker, of course, you install runC and Containerd. If you check it, you can use a help command of runC if you want to have some details. You can find here some specification about runC. This is the version of the Golang language, libsecconf, and other stuff. The version of runC, for example, here, and some argument that you can pass to the runC command, like create to create container and other stuff. So when we tell it, we need to an example to create a container. Just to create a container, how we can do it with runC. So I just open another terminal, Vagrant SSH Docker 1 on the same virtual machine. Here, okay, and we just want to run a simple container. To do it, I need to create. So I create a simple directory to organize my stuff, and I create root fs for file system. We need to create this directory to implement a Docker container. And after that, what I can do, I need to have a container image, like Nginx, for example. So to do it, I need to download this image in targz format and extract it into the root file system. So to do it, I run this command docker export to export the targz about a specific Docker image, and docker create nginx. This is to create a Docker container not running, but to extract about it our file system. So now if I check into the root file system, I have a file system about my nginx image or container. This is better to say image. And now I need to create another file name config.json, and in the config.json I can define all characteristics about my my future container. So I edited it, config.json here. We need to edit it on the side about the root fs, root file system. So here I can push the content of my file, and this file is very, very important. This is how we implement Open Container Initiative model. So you can pass many options into it. For example, here we push args. If we remember well, args is like the entry point, how you run, which command allows you to run a container, nginx, but in our example, we want to run an nginx. We want to run a sleep with infinity. Another stuff like how we define the root file system, where runC can find the /sys directory. I think you have the same with /proc, yeah, here, and other stuff to run a container. It's very, very important. Here. So when we do it, we can now run a container with runC run command and the name of this container. And by default, runC use the config.json file, and this file allows you to run all the file system in the root fs. So I want to run container 1 here, and now we have our container. We don't need to download the image because we already download the targz about this image, nginx image. And now we can run runC list, if I remember well, yes, runC list, and this is like our docker ps command, if you remember well. We have the name of this container, the PID of this container, the status, and where the bundle is stored, and when we have created this container, and the owner, of course, we are root. Okay. After that, what? If we check. After that, yes, how of course we kill this container. We can kill or destroy this container with run kill command. If we just runC kill container 1, I think this is a simple kill. So in our case, we can just send a sig kill, for example, and we have destroyed our container. If I check runC list. No container are listed. Okay. So now this is for low level part, and now in high level part, the first level of this high level part, we have containerd, and we can create a container with containerd. So if we just want to run a container with containerd, this is easier than runC, of course, because this is a high-level container, and to do it, container runtime, and to do it, we just need to run ctr for containerd, image pool, like a Docker pool command line, and the address about our image. In our case, this is docker.io / library / nginx, and the tags to latest. So I download this image. This is like a Docker pool, not exactly the same command, because Docker pool use caches and some other stuff. And now we can image ls or list ls, okay, and I can see my image with digest, labels, platform here, where we can run our image, for example IRM and some other architecture, the location about this image, and that's it. And now we want to run, of course, our container, nginx container, and to do it, we just run ctr run, and our image, we have already downloaded it with the pool CLI, and when we run it, we run our container. So we can list our container with ctr-c or ctr container list, ctr-c list, for example, and we have our container. This is very useful to know how to manage a container with ctr CLI or containerd CLI, because when you use Kubernetes, for example, sometimes you need to go on the worker node and to debug, manipulate, or manage a container, or debug or troubleshooting a container with this CLI. And specifically with Kubernetes, Kubernetes use a namespace. If you run ctr, you have the help. This is like the help argument, and you can pass namespace value here in the ctr command, for example, like this. And if I remember well, in Kubernetes, we are in a namespace, not namespaces like operating system, but a namespace about containerd namespace. This is just a box where you store many stuffs, many containers or images. And in Kubernetes, if I remember well, I think this is kates.io namespace. So in our case, this is not what we have. And we can list, of course, our container. If I remember well, this is here ctr-c or ctr container list, like this. And we can find our container, my nginx, the image of the source of our container, and the runtime here. Okay, now we can go ahead and check some things. For example, we can just check that with containerd we set namespace. For example, you can for example, when you use containerd, of course you can list here your container, but if you check with for example a netstat command or other command, you can check if you are if you have a port 80 listening. But when we check, we can't see any port 80 on our interfaces. So how we can be sure that we have a container Nginx running? So we need to check. We need to, of course, we haven't any process listen on port 80 about our virtual machine, but when we change our network namespace, we can check if in the namespace about our PID, our Nginx PID, we have our port 80 listening in this context, in this network namespace. To do it, we can we need to find the PID of our Nginx. For example, if you can just run ps command and check that we have an Nginx. Of course, we have an Nginx. I think this is this PID, yes. And now we can use ns enter command and dash p. No, sorry, dash target option with our PID, and we can just here run dash net to be in the network namespace about this PID. So not this PID. Which PID have we got here? Here we have. Sorry, this is better in this format. 6607. Yeah. Okay. So we don't see any change, but when we just run a curl in 127.0.0.1, we have our Nginx. So we are in the network namespace about the specific PID. This is the PID 6607, and we are in the specific network namespace. If we check the list about our interfaces, we have only one interface, the loopback, and the loopback is the common IP 127.0.0.1, and if we just run a curl on this IP, of course, we target our Nginx process in the port 80, and it works. Okay, so ctrl plus D and exit, and now what we can do, we can just check when we run a container, if we want to do the loop and to close the loop with the behind the scene about Docker container, we can just run a container, an Nginx container. You can stop this one here, and in the detach mode, the name of this container, for example C1, and for example we can set the max memory allocated to our the max memory allocated to our container. For example, we can just set 1 gig of RAM, and the image, of course, Nginx in our case, latest, and that's it. We can run it. Docker PS, we have our container, and now we want to check that we have a limit about our memory. So we can run Docker, for example, Docker stats command. I don't know if we have already seen that. We have 1 gig of limit. Okay, this is correct. And now we can check that to create this container, we have some namespaces, and to do it, we can use the command lsns for ls namespaces and the PID of our container. So to check the PID, check out this PID, we can just run a docker inspect c1, and at the beginning of this output we have the PID of this specific container. Okay, so I can do a lsns -p and the PID of this container, and this is the list of all network namespaces, not only network namespaces, and we have a network for time, user, mount, UTS. This is for the time, if I remember well, IPC, inter-process communication, PID, because when you run a container, remember that we have the PID 1 into the container. This is our process. So this is allowed by the PID namespace. The network namespace, we already see that with the previous demo, and the cgroup namespace. And the user, of course, because we don't have the same user into our container and our virtual machine, we can remap a container, for example, and the time, and the name, maybe is the name, this is maybe UTS namespace, because when we are into the container, we can use another name. We have another name for our container. This is not the same name of our virtual machine. For example, here we have Docker 1, but if we go into our container, for example, here this is a C1 container with a dash. We have this host name. Can check with host name. We have this host name. This is not the same host name into our container. This is allowed by namespace. That's it for today. Remember that you can subscribe to the channel to not miss the next video, and see you next.